Hai, Assalamualaikum. My name is Siti FATIHAH binti HASZLAN.
My name is MAISARAH binti IBRAHIM.
My name is SARA binti NORANI.
My name is Munira binti MOHAMAD.
For our group, we choose two topics. The first one is about the half-man code from chapter 4.
But before we start, what is half-man code? Half-man code is a type of optimal prefix code that is commonly used for lossless data compression. The technique works by creating a binary tree of nodes. Node count depends on the number of the symbol. Now let's see an example question of half-man code.
For example, we want to encode the symbol S into a binary code. So let's see, S is here, and if you go down the binary tree, you will meet 1. And then you will going to meet 1 again until you meet S. So the binary code for symbol S is 1, 1. Try encode symbol A into binary code. Start from the top and then going down the binary tree, going to meet 1 and then go to node A and you will meet 0. So the binary code for A is 1, 0. The binary code for symbol E, see E is here, just going down the binary tree until you meet E. So the binary code for E is 0, 0. What is the binary code for N? Just going down here like 0, 1, 0. So the binary code is 0, 1, 0. For P, 0, 1, 1, 0. For L, 0, 1, 1, 1, 0. And for D, 0, 1, 1, 1, 1. From the table that we have made before in the previous slide, we're going to use it to decode this number. First, 0, 1, 1, 1, 1, which is, if you see from the table, 0, 1, 1, 1 is equal to D. Next is 0, 0. See from the table, 0, 0 is equal to E. 1, 0. 1, 0, if you see from the table, it is A. And the last number is 0, 1, 0. 0, 1, 0 is N. Now how to encode this symbol into a binary code? Refer to the table that we have made before, and first letter is S. You see from the table, S is equal to 1, 1. L is equal to 0, 1, 1, 1, 1, 0. E is equal to 0, 0. 0, 0 again, and P is equal to 0, 1, 1, 0. Now, let's try another question. Try to encode this symbol into a binary code. Binary code for symbol O is 0, 0, 0. Binary code for L is 0, 0, 1. Binary code for F is 0, 1. The binary code for B is 1, 1. Binary code for E is 1, 0, 1. 2 is 1, 0, 0, 1. And last, binary code for T is 1, 0, 0, 0. Now let's try to decode this binary number. So for the first symbol is 1, 0, 0, 0. If you refer from the table, 1, 0, 0 is equal to D. And the next binary code is 1, 0, 0, 1, which is equal to U. Next is 1, 1, which is equal to B. And 1, 0, 1, the last letter is 1, 0, 1 is equal to E. Now how to encode this symbol? Refer from the table. For B is equal to 1, 1. E, if you see from the table, E is equal to 1, 0, 1. L is equal to 0, 0, 1. Last letter is T. T is equal to 1, 0, 0, 0. So the binary code for belt is 1, 1, 1, 0, 1, 0, 0, 1, 1, 0, 0, 0.
So that is all for topic 4. Now let's move on to the next chapter.
The second one is about basic connectives and truth table from chapter 5. For basic connectives and truth table, it is about logic. We use logic every day in our lives. We determine whether a statement is true or false, but not both. Compound statements are the statements that contain logical connectivities, such as not, and, or, if, then, if, and only if. Next, truth table exists to represent all possible true values of a statement.
Alright, negation is translated as not or it is not the case that. The negation of statement P is denoted by not P. The effect of the symbol not on the meaning of a sentence is illustrated by the following table, which is called a truth table for not. Next, conjunction. Conjunction is translated as and or sometimes but. The conjunction of the statement P, Q is denoted by P and Q. In our example, the statement P and Q is read, this book has 100 pages and its cover is green in color. The statement P and Q is true when both P and Q must be true. If either P or Q is false, then P and Q is false. The third one is disjunction. Disjunction is translated as or. The disjunction of the statements P, Q is denoted as P or Q. From the previous example, the statement P or Q is read, this book has 100 pages or its cover is green in color. Consequently, P or Q is true if one or the other or both of the statements P and Q are true. Next, implication. Implication is translated as if, then. If consider the statement P implies Q. If I eat ice cream every day, I will be happy. The statement P is called the hypothesis of the implication. Q is called the conclusion. The truth of P implies Q is false only when the hypothesis P is true and the conclusion is false. For other cases, the truth value of P implies Q is true. The last one, biconditional. Biconditional is translated as if and only if. From the previous example, the statement P biconditional Q is read, this book has 100 pages if and only if its cover is green in color. the statement P by conditional Q is true whenever P and Q have the same truth values.
Now, let's take a look at question 1. State which of the following statements are propositions. Then, give the truth values of the propositions. Remember, propositions are either true or false, and it cannot be both. A. All even numbers are divisible by 2. This statement is true, hence, this statement is a proposition. B. Load the package in the car. This statement is neither true or false, so this is not a proposition. C. Jupiter is the closest planet to the Sun. This statement is false. However, we still consider it as a proposition because it has a truth value. D. Hard disks should never be stored in the microwave. This statement is true, so we can conclude that this statement is a proposition.
Question 2. Let P, Q, and R be the following statements. P. He reads comics. Q. He loves science fiction. And R. He wants to be a computer scientist. Express the following statements as symbolic expression. For question A, if he reads comic books and loves science fiction, then he wants to be a computer scientist. So first, we need to identify which is P, Q, and R from this sentence. Here, we can see that he reads comic books is P, loves science fiction is Q, and he wants to be a computer scientist is R. Next, in this sentence, we could see that this sentence has and, so we know that it is conjunction. After that, there is if, then, so it means it is implication. Thus, the answer for this question is P and Q implies R. Question B. He loves science fiction is a necessary condition to be a computer scientist. He loves science fiction is P, and to be a computer scientist is R. Next, in this sentence, it says is a necessary condition, which means that this is the logical connective for implication. Hence, the answer for this question is R implies Q. Last question for this part, C. Only if he wants to be a computer scientist, then he must love science fiction. So, he wants to be a computer scientist is R, and he must love science fiction is Q. There is only if, then in this sentence. So, we could clarify that this logical connective is biconditional. So, the answer is R if and only if Q.
So what can we conclude from these examples about propositions? I can summarize that propositions are sentences that are either true or false, but not both. Second, if the sentences are neither true or false, it does not consider as propositions.